This video is about air conditioning units, specifically NEC and IRC requirements, how to properly size your conductors and overcurrent protection, and how to pass your AC inspection. References today are taken from the 2020 NEC and the 2021 IRC. You want to always remember to check with your local AHJ, authority having jurisdiction, and your local and state codes. Typically for sizing motors, we go to Article 430 in the NEC, but for refrigeration equipment and air conditioning, NEC sends us to Article 440. Once we're in 440, if we go over to 440.1, the scope article, it tells us that we're in the right spot. This is for refrigeration equipment or air conditioning units, but it also says that it's specifically for hermetically sealed motors and compressors. If we read a little further down, then we come to Article 440.3, which is called Other Articles, and it tells us that if it isn't a hermetically sealed motor, we're going to refer back to the typical sections of the NEC that we would follow for other type motors. In order to better understand the differences between a hermetically sealed motor and a standard motor, we can go to Article 100 of the NEC, and it tells us that it's a combination motor and compressor in a sealed housing that are actually operating within the refrigerant. There's no external shaft, there's no seals, external seals, so it's actually being cooled by the refrigerant that's being produced. One of the benefits of the windings being cooled by that coolant, as an example, is a 1.5 horsepower motor might be able to produce 2 horsepower worth of work because of that cooling effect that's taking place. If we continue in the NEC, we go to 440.4b, which is combination load equipment, which would be a typical AC unit. You have the motor compressor, and then you also have a motor for the blower. And it tells us that in these cases, the manufacturer is required to put a tag on the unit that's going to tell us things like phase, voltage, but also it's going to tell us maximum overcurrent protection and minimum circuit ampacity. So in a standard motor where we would have to calculate those things or figure that out by the information we had on the motor, in these circumstances, combination equipment, the NEC tells us that the manufacturer has to provide it for us, and it makes it easy for us. So we know exactly what the overcurrent protection is required, or the ground fault protection, and what the minimum circuit ampacity is. So the manufacturer's tag is going to provide for us the ground fault short circuit protection, or as it's listed on the label, maximum fuse and or circuit breaker, and minimum circuit ampacity. So after we get our minimum circuit ampacity on our tag, we're going to go over to our ampacity table 31016, and we're going to determine what size conductor we need for that ampacity. And we're going to assume 75C, that our connection points, our lugs are 75C rated. The wire type, we're using a wire type that is rated for 75C. If your wire type is not rated for that, then you're going to have to go to the 60C column, but we're going to assume 75C. And if we look at the notes section, the asterisk section says to go to 240.4D, and it tells us that there's certain limitations placed on conductor sizing. So we're all very familiar, as electricians, you're familiar with that number 14 and with the asterisk, and with 240.4D tells us that you can only go up to a maximum of 15 amps, a number 12 maximum of 20 amps, a number 10 maximum of 30 amps. But you have to read the last part of that note, which says, except as modified elsewhere in the code. So this is where it leads us to another section of the code to see, is it modified? Is it modified for air conditioning equipment? And yes, it is. And the code goes on to tell us, unless specifically permitted in 240.4E or G. And in 240.4G, it tells us that air conditioning equipment, refrigeration equipment has to meet the requirements of 440 Part 3 and Part 4, which is where we started. And it tells us again about the manufacturer tag, and that the tag has to be provided, and it has to give us that minimum circuit ampacity. And specifically, 440.35 tells us that the ampacity of the conductors supplying multi-motor combination load equipment, which our air conditioning equipment is, it has to meet a manufacturer's marking on the equipment in accordance with 440.4B. So it brings us back where we started. So that particular equipment, they provide for you the manufacturer's requirements for minimum circuit ampacity, ground fault, short circuit protection, or the breaker and or fuse for that particular piece of equipment. Okay, so let's walk through a couple examples. So on this tag, it tells us maximum fuse 25, maximum circuit breaker 25. So the tag has to say fuse or circuit breaker, or it can say both, meaning you can use either. So on this particular tag, we'd be able to use either a fuse or a circuit breaker. It tells us that the minimum circuit ampacity is 15.1 amps. So if we go over to our table 31016 and we look at a number 14, we find in the 75C column that a number 14 is able to carry 20 amps. So number 14 would be acceptable for that installation for our minimum circuit ampacity. Okay, let's look at an example of another tag. So on this particular tag, it tells us maximum fuse / breaker. So you can use either or, and it tells us it's 45. And another note to bring up here, you can put in less than 45 if you want to, and it meets the manufacturer's requirements, but it just cannot be more than 45. So the maximum is 45. You can go less as long as the unit's not going to trip out. It tells us minimum circuit ampacity on this unit is 28 amps. So let's go over to our chart and see what our minimum circuit ampacity is based on 31016. So based on table 31016, we see that a number 12 would only be able to handle 25 amps. So we would have to go with a number 10, and a number 10 in the 70C column would be 35 amps. So that would be plenty for this installation. NEC 440.14 talks about our disconnect. The disconnect has to be located within sight of the unit. And also something that's sometimes been a gray area as far as the disconnect, it does have to meet the requirements of 11026. It's been gray in most code cycles, and now in the 2026 code cycle, or actually the 2023, they make it very clear, and they say it has to meet NEC 11026, which is the 30 side to side and 36 out in front of it. Oftentimes, the electrician will put the disconnect in, and then the HVAC installer comes later on to put the unit in, and he puts it right in front of the disconnect. So it is supposed to meet the requirements of 110.26, and it's clearer now in later code cycles. They actually call it out and state that it has to meet that. Now, from the disconnect to the unit, the code allows some type of a flexible conduit, like a liquid type flexible conduit. But an EGC, equipment grounded conductor, always has to be provided, because according to 250.118, they want an EGC of the wire type provided for any equipment that has vibration issues, so that there's a solid fault path back from the unit to the disconnect back to the source. Now, the class 2 conductor that goes from the furnace to the contactor and the AC condenser, as you see in this photo here, can be run and strapped to the seal tight that's going to the unit itself. One of the violations that I run across a lot, and I think that electricians think it's okay, is to run that class 2 with the power conductors. But if you look at 725.136 of the NEC, it tells you that you cannot run class 2 conductors with power conductors. And I know as an electrician, I thought many years ago that was okay, but that isn't something that you can do. You have to follow the separation requirements or not run it in there at all. And this is normally the way you see it. A lot of times on multifamilies, apartments, you'll find that the class 2 was run with the power conductors, and that does not meet the code. It's a violation of 725.136. NEC 21063 says that equipment requiring services, you have to have a receptacle within 25 feet of the equipment. In this particular disconnect you see here, it has a GFCI. It's outdoor, so it'd be GFCI rated, and it's part of the disconnect. But within 25 feet of equipment requiring servicing, which AC equipment does require the servicing, you'd have to have a receptacle. Okay, so the other items we look at pertain to the IRC in the mechanical code section of the IRC. And in 1305.131, it tells us that the unit has to be supported, it has to be level on some type of material that keeps it a minimum of 3 inches above grade. If it's suspended, it has to be a minimum of 6 inches above the floor. 114.11.3 of the mechanical code talks about the condensate line, and it tells us that that condensate line has to have a slope of a minimum of 1/8 an inch per foot. Section 14.11.3.1 of the mechanical code also tells us that if a unit is placed in the second floor, in an attic, somewhere where it's not seen, or where there wouldn't be a conspicuous area where you would be able to see if the pan was overflowing, you're going to need a pan on the unit, and you're going to need an auxiliary or secondary drain. And that's if you can actually see it draining. If not, if it's somewhere where you're not really going to see it, you need to have a shutoff, some type of a shutoff, so that if the pan started to overflow, it would shut the unit down and somebody would go and check on it and know that there was some type of a problem. Okay, so those are the things that we look for in an AC inspection. I hope this helped. I hope it helps you pass your next AC inspection. Let me know in the comments if there's other videos you'd like me to do. And also, if you like the video, give me a thumbs up and remember to subscribe. And thanks for watching.